Good afternoon, everybody. My name is Sylvia Roger, and I'd like to welcome you to today's webinar by Professor Andrew Whitehouse on intervention for infants showing early signs of autism. Autism CRC regularly holds webinars such as this one to help raise awareness and understanding about autism and to share some of the Autism CRC's latest research and outcomes across our three programs: diagnosis, education and adulthood. But before we get started, we'd like to go over a few items so you know how to participate in today's webinar. You're listening to this webinar using the computer's speaker system by default. If you'd prefer to join us over the telephone, just select telephone in the audio pane and the dial-in information will be displayed. While you are all on mute at the moment, you have the opportunity to submit text questions to Professor Whitehouse by typing your questions in the questions pane of the control panel. You may send these at any time during the presentation and we will collect them and address them at the end of the presentation or potentially as we're going along. Professor Whitehouse directs the autism research team at the Telethon Kids Institute at the University of Western Australia in Perth, and he's Program Director for Program 1 within the CRC. His research team investigates the genetic and the neurodevelopmental causes of autism, and he conducts a range of clinical intervention trials about this condition. Professor Whitehouse has published over 120 peer-reviewed journal articles, as well as 2 books and 2 internationally used clinical assessments. He currently writes a popular column on child development for the news website The Conversation, which has attracted more than 1 million unique hits. Professor Whitehouse has been a fellow at the University of Oxford and is currently the Winthrop Professor of Child Development at the Telethon Institute for Child Health at the University of Western Australia. He leads the Autism CRC Diagnosis Research Program that we fondly know as Program 1. And in this program we aim to significantly reduce the age of autism diagnosis, enabling children to link into appropriate intervention early. We aim to use cutting-edge genetic and biological research to enhance the accuracy of early diagnosis so we can match children to the best, most effective early interventions. I'm going to hand over to Andrew now to talk you through very early intervention for infants and toddlers. Thanks, Andrew.
Thank you so much, Sylvia. That's a lovely introduction. Rather cringeworthy when you referred to me, but thank you very much. And it's a real privilege to be doing this webinar today. I've done a few of these before, and they're always a bit of a difficulty because all I can see at the moment is myself. And when I look at myself, all I can see is how degenerate I look without shaving. So I must sure I run a razor over my face occasionally. But what we have today is a webinar about what I really dedicate my researching life to, and that's how we can identify kids with autism as early as possible, and also to develop how can we develop new and innovative methods for infants who have a high likelihood of developing autism. Now, please do submit your questions, as Sylvia said. All I see on my computer screen is a question pane, so I'll try and answer some questions as we go, but I'll talk for about 40 minutes now, and then at the end we'll also have 20 or so minutes for question time. So please sit back and relax. This is being videotaped, and so the slides will be available afterwards. So don't feel you need to rush through and make any notes. Okay. Oh, let's see if we can go. Okay. So as I mentioned, what I'm going to talk to you today about is basically the existing paradigm that we have for autism about diagnosis and intervention, and saying that, well, look, I actually don't think that's working as best as it can, and what is a new paradigm for how we identify, diagnose and provide therapy to individuals on the autism spectrum that might be more effective, and I want to lay the groundwork for that. Firstly, I really think it's really important to, for an audience to know who they're hearing from, and I probably don't know most of the people on the webinar here, so here's a short introduction. This is a slide that I give at most presentations, so please excuse me if you've seen it before. I originally trained as a speechy originally. I'm one of the very few males to have ever done the course, and that's me right there. I actually came from an all-boys school into an all-female speech pathology degree, so it was a baptism of fire into the opposite sex. I then did my PhD at the University of Western Australia under Murray Mabry, and that was in psychology, and then I jetted off and spent quite a few years at the University of Oxford, where I became what's called the Fellow of Autism of the University, and that's basically somebody who investigated autism and how we can help individuals on the spectrum reach their full potential. After that, I came home in about 2009 to the Telethon Kids Institute, and that's in Perth, Australia, and that's where I trained, sorry, that's where I was born and bred, and so I came home, and I now direct a team, and I think my next slide has it, it does, a team of about anywhere between 17 and 20 researchers who really are interested in many questions to do with autism, particularly how we can help individuals on the autism spectrum reach their full potential. Okay, that little pop-up there is just basically saying that we're very keen to ensure that everything we do is not just based in international collaborations. We can't do things in isolation. We must do things with the rest of the world, but in collaboration with government. There is absolutely no use doing what we do unless our findings are understood by government and incorporated into new policies. So our philosophy, I'm very much a believer for research's sake, but it's actually not what gets me up and going. Everything I do needs to have a purpose, and I need to connect that to the purpose. So we, the team that I am very fortunate to lead, have a sort of a philosophical document that we follow. So the research that we do seeks to improve lives, and that means that everything we do has to be connected to the ground level. There's no use doing something that won't be acceptable to families, feasible to implement for clinicians, and ultimately effective work. And everything we do has to have those very clinically oriented goals. As I said before, and this probably makes us slightly different to a lot of research groups, is everything we do must be connected to policy. We have grand visions for how individuals on the spectrum can become accepted, far more accepted than they already are, within society, and that involves involving government. And so a lot of my time is actually spent talking with government and working out ways that we can help them develop better policies. And developing research infrastructure. We have a very fortunate ability to develop large pieces of infrastructure that can buttress the autism research environment within Australia. Our goal is to develop these resources that other people far smarter than us can come and develop better research and better outcomes for individuals on the spectrum. And the last thing is to build a community. Everything we do is for the autism community, and we're very proud to be part of that community, and that means conveying information. And so that's our Facebook page there, and just to let you know that every week we put out a 60-second video of a recent recent research paper that's been released, and we describe that paper in layperson's language, and that hopefully can be translated onto the ground. So like that page if you'd like to receive them. Okay, I also start each speech presentation by talking about what I believe autism is, because autism is a concept that does change over time, and it can mean different things to different people. This is how I view autism. So autism is a neurodevelopmental condition, which means that something happens early on in development to make the brain develop differently. We currently diagnose autism based on social communication difficulties and repetitive behaviours that affect functional abilities. as we know, symptoms vary wildly in severity, and we have a very busy research clinic where in my group, and these are just two children who might walk in to our clinic one after the other. One has quite severe difficulties and might have a lifelong disabilities that need to be managed. The other child might have IQ within normal limits, able to engage in conversations, but will always have slight difficulties with social and communication abilities. And of course, with autism, it's every flavour in between. There really is no two individuals with autism who will present similarly. And that also goes for the genetics and the neuroscience, and I'll talk to you a bit about that in a bit. Autism, when I started, was considered to be about 1 in every 2,000 people. Now autism is at least 1%, and certainly there have been prevalent studies that have said 1 in 38 or 1 in 36. I mean, it's very, very far more prevalent than when I first started in the field, and this is more than the combined numbers of children with CP, diabetes, deafness, blindness and leukemia combined. And this, of course, is not downplaying the importance of these conditions. It's just telling you that the public health issue that we need to help. Genetics. We know that autism is a heritable condition, which means that it runs in families. It's transmitted through genetics. Now, I talked to you a bit about genetics later in the presentation. What we do know is that most of the genetic variants that lead to autism are inherited, but others are what we call de novo, which means that when the sperm and the egg meet right at the very first cell, there's a new genetic variant that wasn't in the mum or the dad that can lead to autism. Environment may be involved in the development of some cases of autism. What I can say, though, is that we haven't identified any environmental factors that are clearly involved in any case of autism at this very early stage. Early identification and intervention are key. Now, this is really where I want to park ourselves for the rest of this talk. And I think I'll go on to the next slide. For many years, people just almost blindly said early intervention is important. It's very important. We must do early intervention without a great deal of evidence. And this always worried me slightly, but I'm very, very pleased to report that over the last 10 years there has been an increasing amount of evidence coming out that autism, a very early intervention with autism does have a major effect on the long-term outcomes of individuals on the spectrum. And there are just some references there. So let's just dissect this for a little bit. Why is early intervention better than, say, early intervention a bit later on? Well, we know that early intervention, I'm talking about intervention ideally less than 5 years of age, even younger would be wonderful. Early intervention, when we're looking at children, the brain is at its most changeable. Absolutely in the first 2 years of life, but certainly within the first 5 years of life. If you've ever seen a child develop, I'm sure you've been absolutely amazed as much as I am at how quickly their brain can learn. Think about just the complexities of developing language. It's extraordinary what a young brain can do. And that's what early intervention seeks to capitalise upon, the way that the brain can adapt and learn during those very early years of life. The second point that I have there is also really important. The interplay with the environment is critical. The way that we engage with our environment can actually entrench disability. Now, if children or individuals on the spectrum early in life are interacting with the environment in a very different way, the disability that they are born with actually becomes further entrenched. If we can get in early enough to change the way that individual children on the autism spectrum interplay or engage with the environment, that actually reduces the entrenchment of disability. And that's a really important point to consider as we move forward in the talk. Okay, now what I want to talk to you about is my dream. As I said, I do believe in research for research's sake, but certainly I'd like to convey to you my dream. Now, my dream is never, ever, ever to prevent autism. I think individuals on the spectrum have just so much to add to our society, and we have so much to learn from individuals on the spectrum. What I want to do is reduce the disability associated with autism. That means helping children who may not otherwise have learned to talk. That means increasing the levels of intellectual capacity within some individuals on the spectrum. Then it means helping individuals on the spectrum gain independence. We're talking about reducing disability, not preventing autism. Now, there is enough studies out there now to actually help us understand that when a child walks into our clinic, what are the best predictors of the long-term outcome of that child? What when a child works into our clinic indicates that this child is going to have a positive long-term outcome? Some of the positive predictors that have been found are a higher IQ, and this is for children who walk into a clinic under the age of 5. Higher receptive language, that's language comprehension, ability to understand what's being said. Higher verbal and motor imitation is also predictive of positive longer-term outcomes, as well as motor development. And that's a really interesting one because it does show you that individuals on the autism spectrum, that the neurological differences that contribute to autism contribute to other things as well, such as motor development and imitation. Now, negative predictors. If a child walks into our clinic and they have these factors, the outcomes can be more challenging. So if an individual has seizures early on, intellectual disability, and also individuals with an identified genetic syndrome, the long-term outcomes don't tend to be as good as for children who don't have these. Now, a very, very interesting aspect of all these studies that have tracked in children over time to adulthood have actually found that the severity of autistic symptoms in childhood, that means social and communication abilities, that means repetitive behaviours, actually they have very poor predictive power as to what the long-term outcome would be. And that's a fascinating so it's quite a fascinating finding that the severity of symptoms early in childhood don't predict long-term outcomes. It's more these other things here, the higher IQ and receptive language. Okay, so how do we achieve my dream? This is just my dream of reducing disability in individuals on the autism spectrum. Well, this is what the status quo is currently. So this is just a lifetime path for well, just development basically. At the moment, and this is, I'm about to tell you what a common tale, it's not by any means the universal tale, but a common tale of individuals who are identified with autism. Parents typically identify kids early on, often less than 12 months, that something is different about their child. They're developing a little bit differently to other children. They often rattle around the health system, and I say that euphemistically, but it's often quite a experience for families. They rattle around the health system till about 2 to 3 years of age, when the autistic behaviours that we use to diagnose autism start to develop. And of course, at around age 3, the average age, or the median age of diagnosis in Australia is 4.5. You get a diagnosis of autism, and of course intervention starts from there. And at the moment we use diagnosis as the main indicator of when intervention should start. And I say that with a very broad generalisation. It's not true in all cases, but certainly in the majority of cases, the point of diagnosis, that is when intervention starts in earnest. Now, how is this profile, how is this clinical pathway faring? And what I'm going to show you now is I don't think it's faring anywhere good enough for what we can do. What the longitudinal studies show is that only about 3 to 25% of children have a significant reduction in disability across their lifetime. Oh, that's so less than a quarter of individuals who receive significant early intervention have a significant reduction in disability across their lifetime. I don't think that's anywhere near good enough. So there we go. We'll just roll it all out. This, I believe, this poor statistic, I think, is because our current interventions aren't as impactful. Anyone who's spent any time with families who have a child on the spectrum know that they can toil for years without a great deal of progress. Certainly progress is made in many children, if not the majority of children, but certainly clinicians, families and individuals on the spectrum can toil for years without a great deal of progress. Far too labour intensive. When I see that the recommended amount of intervention is between 20 and 40 hours a week, I just despair. There is no family, or very few families can A, afford that, B, have the time spare that they can invest in that without a significant impact on their family life. We need to find better ways to do that. And of course too expensive. The financial impost of this kind of therapy is significant, and very few families can afford that, and certainly our public health system can't afford that, so we need to find better ways. Now this is the way, This is just a little slide to say that I think we've been banging on about the same paradigm of diagnosis at 3, intervention beyond there far too long. We need to find a different way of doing things. And so I think it's time for a new paradigm. We need to find a new way, a new clinical pathway for autism. And basically what I'm saying is that let's now have a formal way of understanding and listening to what parents are telling us. Parents are telling us that far more often than not, they are identifying their child as developing differently early on in life, during those very, very important years, the first 2 years of life when the brain is at its most changeable. So let's keep the importance of diagnosis, but let's not use diagnosis to indicate that therapy commences. Let's start looking at infants, so within the first 2 years of life, who are showing early signs of autism, and move the age at which we start intervention back to those very, very crucial years. This is not to say that diagnosis is important. Diagnosis is important, but that should not be used as the trigger for therapy. We should be using the very early signs of autism as our trigger for therapy. And I'll start to talk to you about where we're at with developing an evidence base for this new clinical pipeline. Okay, so the new model. All right, so, excuse me, coffee. What this new clinical pathway hinges upon is finding a way to identify with good facility infants, let's say 12-month-olds for argument's sake, that have a high likelihood of developing autism or getting a diagnosis of autism at, say, 36 months of age. Now, the key statistic here is something called positive predictive validity. Basically, that means that at 12 months of age, if a child is seen to demonstrate X, Y, and Z behaviours, what is the percentage chance that those children will then go on to develop autism? Okay, so that's what we're trying to develop, an evidence base for a high positive predictive validity at 12 months for a diagnosis of autism later on. How are we going with that? Well, still, the greatest likelihood factor that we have out there is a family history of autism. If a child has a sibling that's on the autism spectrum, we know that there's about a 20% chance that child will also go on to develop autism. That positive predictive validity of 20% is still too low for public health systems to say we need to provide universal health care to these children from a very early age. So we start to look at, okay, what happens if a sibling or other children have certain behaviours that they're showing at 12 months of age. And here's a few screeners that I've popped up there. So there are things called the first year inventory, there's something called the ESAT, or the early screening for autistic traits, and there's something called the MCHAT, which many of you have heard. Now, the first year inventory has a positive predictive validity of 31%. That means that if there are children at 12 months of age who are scoring above a certain threshold on this tool, it's about a 31% chance that they're going to develop receive a diagnosis of autism later on. The ESAT, it's about a 25% chance. Now the MCHAT, which is a much heralded tool, at a later age, 16 to 80%, it's only about a 12% chance that if a child scores above a certain threshold, they'll go on for a diagnosis of autism. So this still really isn't good enough for us to go to the health system and say, if children are screening above a certain threshold on these tools, that they should receive intervention. They will say, well, actually, that the positive predictive validity isn't high enough, and for example, for the first year inventory, there's still a 69% chance that children won't go on to develop autism. So we need to find better ways. Behaviour still remains the best predictor. So despite those poor statistics, behaviour at 12 months of age still remains the best predictor of whether a child will go on to develop autism. These are several behaviours that I've pulled out of a lot of the different tools that are out there that at 12 months of age, if a child isn't showing these behaviours, seem to indicate a higher likelihood that develop autism. I haven't validated, it's important for me to say, I haven't validated these in my own tool or anything like that, but these seem to be quite consistent in being the behaviours that are pulled out that indicate a likelihood of developing autism later on. So response to name. So if a child, you have a few attempts and the child is not responding to their name at 12 months of age, that seems to be one possible predictor of a diagnosis of autism later on. Poor quality and quantity of eye contact, poor imitation. of motor movements. Proto-declarative pointing, so that's pointing to another object to describe interest to a parent. So for example, if I'm a toddler and I point over there to show a teddy bear to my mum, that's also shown to be a predictor of autism a bit later on. And then joint attention, that's actually following the attentional cues of a parent or another person to engage in enjoyable activity. Now, all of these behaviours are predictive of autism, but again, the predictive validity of these are actually quite small. So we still need to find better ways to identify infants at a higher risk of autism later on. Now, the one reason why I think we need to move beyond behaviour, well, another reason why we need to move beyond behaviour is because behaviour during infancy is so variable. I mean, I see kids in our clinic that aren't saying a word at 2 years of age, not a word, even at 2.5 years of age, and they go on to be absolutely without difficulty later in life. Similarly with repetitive behaviours, and hand flapping is one that often comes to me. It's a very, very, very rare child who doesn't flap their hands in response to something that's exciting. It's actually a really typical behaviour. So it's very difficult to understand what is typical behaviour and what's indicative of risk. We need to move beyond behaviour, and that starts to involve some biology. Now, I just see a question there that's popped up. What are my thoughts on the SACS? And the SACS is something, this is the Social Attention and Communication Scale. This is something that's the CRC is quite involved in. Now, this is a scale that is administered by either a parent or a health professional to a young infant to indicate risk. I think it's a very good tool. I think it's a really good tool, and actually a lot of these behaviours that I identified there are identified in the SACS. So I do think it's a very good tool. We need a bit more a scientific measurement behind it, but the CRC has invested in that as well. So I hope that answers the question. Now, we know that autism is not one condition. It's many, many, many different conditions, but nevertheless, there might be ways that we can identify autism using biology very early on. The difficulty with autism is that we don't have any overt physical markers, of course. For example, I've got some examples there. There's the brain tumours, there's atopy or allergies, and there's blood glucose levels for diabetes. They're all very clear markers of what autism, what a condition might be. Autism doesn't have that. All we have is this, a gorgeous little baby sitting in front of us who might show some very slight behaviours that indicate risk. And so we need to use all of the things in our arsenal: genetics, neurocognition, physical and biochemistry. What I want to concentrate on today, and I'm going to zip through these, this is a lot of what the CRC is quite interested in. At 12 months, can we identify biological risk markers or likelihood markers that might be able to be used in conjunction with behaviour to indicate risk for later on? Now I'm going to have to zip through these. Let's start on the first one. What I'm talked about is surely we can get to the stage of having a blood test from birth to identify kids that are at risk, a high likelihood of developing autism, similar to what we do already with the Guthrie card with cystic fibrosis and a few other conditions. Well, yes, we can. They're in about 10 to 20% of cases of autism. What we actually do identify are clear genetic vulnerabilities that lead to autism. That's only in about 10 to 20% of cases. The rest, 80 to 90% of cases, we still don't have very clear genetic markers of what has led the brain to develop differently. Now, the major problem with using a blood test at birth is the issue of genetic penetrance. Now, this is quite a highfalutin scientific term, but it's a very simple concept. Penetrance is the percentage or the percentage chance that an individual carrying a particular genetic variant will express a given phenotype. Now, basically what that means is that if an individual has this particular genetic mutation, what is the chance that they'll actually have autism? Now, in some cases, that's actually really high. So, for example, a mutation on this particular chromosome, this particular gene, it has 100% penetrance. So all of the cases ever recorded in the world that have a mutation on this particular gene, children do develop autism. But that's a very rare case. And in fact, there was a mutation identified last year on 16p11.2. That's basically the top part of chromosome 16. It was much heralded to say that if children have a mutation here, it's a very high likelihood that they're going to develop autism. What subsequently happened is studies found out that the penetrance of this was only very, very small, 15%. So the percentage chance that if the child has the mutation on this chromosome, or this place on this chromosome, it's only still a 15% chance that they'll have a diagnosis of autism as well. So the penetrance is very low, and that's why the idea of using simple genetic markers to identify risk for autism is not going to be a very simple fix. Okay, let's talk about eye tracking. Now, I'll move through this very quickly. We don't need to look at that. Eye tracking is a very, very cool tool because it helps us essentially get inside the child's brain to identify what they're looking at. What we have here is, yes, I hope you can see my little my mouse here, is this here. This locks onto the child's pupils, and actually it helps us understand where the child is looking on the computer screen. Now, what the studies have found is that, there's a very simple paradigm, I'm going to go through it quite quickly, is what happens is the child is looking at a screen and then it pops up. A clown pops up and that attracts the infant's attention. This is a 6-month-old infant here. And what the 6-month infant then sees on the screen is a balloon pop up. And all we see, all we measure is how long it takes the infant to disengage their attention from that clown and then re-engage their attention in that different stimulus, the balloon. Now, what we find with infants who go on to develop autism is that actually the time that it takes to disengage from one stimulus and then re-engage with another is a little bit longer than infants who don't go on to develop autism. Here is some data. What we're looking at here is the main thing that I want to show you here is that for the majority of infants who don't go on to develop autism, over time from 7 months of age to 14 months of age, the time that it takes to disengage and then re-engage, they actually get quicker with this as they develop. But what we see with infants infants who go on to develop autism from 7 months to 14 months of age is that they actually start to take longer in their ability to disengage from one stimulus and then re-engage in another one. This is work coming out of the BASIS group in the UK. And so what I want you to start thinking about is how that might actually play out, and this is for the clinicians in the audience, how this might start playing out in social interaction. It's the same for parents. How do you think if they take longer to disengage and then re-engage, what do you think that might look like when you're interacting with an infant at that age? And I want you to keep that in your mind because I'm going to talk to you about an intervention trial that we're running soon that really seeks to tap into this. Okay. The second thing here, and this that photo comes from a group in Harvard, but the research in particular is coming out of the BASIS group again in the UK. Now, what I want to show you here, now again there's quite a lot of stuff on the slide, but I'm running a bit behind. So all I want you to show here is that during infancy, when a person directs their gaze towards us, we show a very clear electrical signal in our brain that shows us as researchers that, oh, when somebody diverts our attention to us, gives eye contact to us, it's a really salient thing where our brain responds in a very clear manner that goes, oh, this is very important. What these studies are starting to show, and again this is coming out of the UK, is that infants with autism, when infants who go on to develop autism, when eye gaze is directed at them during infancy, they don't tend to show that big bump of electrical signal that shows that, oh, that eye contact directed towards them is important. Now, they still do show a little bit of electrical activity in response to that eye gaze direction towards them, but it's certainly not to the same extent as infants who don't go on to develop autism. And again, I want you to start thinking about this in the context of how we can start to tap into this in our interventions during infancy. The last risk factor that we're looking at is the facial phenotype. Now, of course, autism is not typically thought to have a characteristic facial structure. Certainly conditions such as Down syndrome or Williams syndrome have a very characteristic facial structure, but there is a lot of data coming out over the last 10 or 20 years showing that maybe individuals on the spectrum might have a different facial structure. It's just that our measurement techniques haven't been advanced enough. Now, what we've started to do in conjunction with Professor Murray Mabry over at the University of Western Australia is we're using 3D photography to take photographs of the faces of individuals on the autism spectrum, and this allows us to analyse facial landmarks with sub-millimetre precision. And certainly what we're starting to find, and we have published on this, and I'd love to come back and talk about this another time because it's a fascinating area, is that at the sub-millimetre level we are finding differences between children with autism and children without autism. But it's only emerging when we use this very high-tech equipment that allows us to create very fine maps of facial landmarks. What we're looking at now is, can we look at facial structure in infants, 12-month-old infants, and see, does facial structure, is that in any way predictive of children who may or may not develop autism? And look, it's an absolutely fascinating area. I'll take lots of questions on this because I can have long and in-depth nerdy talks about this. So look, what I want to show you just by that very quick wraparound tour is to show you that behaviour is still the best predictor at 12 months of age of children who will go on to develop autism or get a diagnosis of autism. But the worldwide research that is out there is showing that we can start to fold in biology. Yes, using some genetic markers. Yes, looking at eye tracking technology and neuroimaging, as well as looking at facial phenotype, that might help us be used in conjunction with those behavioural markers to then actually say, well, instead of a 30% positive predictive validity, if we use these other things in conjunction with behaviour, it bumps up to about a 60% positive predictive validity, and that's the dream. If we can find around 60, a suite of predictors, I think I've got this next, a suite of predictors at 12 months of age, that would start to tell us with greater surety that this infant has a high likelihood of developing autism, then we can convince the health system to say we need to invest in these children to help promote best long-term outcomes. So that's not all. Once we've identified these children, we have to develop interventions. All the interventions that we've been developing are for children and adults, not for infants. And so what I'm going to do is round off my talk by talking to you about a very early intervention trial, and by very early I mean with infants who are showing early signs of autism. Okay. Now I've talked to you about the entrenchment of disability. This is a model I like to use in a lot of my talks. Individuals on the autism spectrum, we know, are born with a genetic or otherwise biological vulnerability that causes them to interact differently with the social environment. Now, we know from a lot of research that right from the very early moments, even when children are in the labour ward after birth, they have an innate social bias. So, for example, there are a lot of studies coming out of maternity wards that are showing that children look far more at the neonates, newborns, look far more at the eyes than the ears. They are born knowing that social interaction is the most important thing for their long-term development. Infants who go on to develop autism, and this is quite a generalisation, but I think that the data are now bearing this out, that some children, infants who go on to develop autism, don't show that innate social bias. Now, of course, if they're not showing these innate social biases for eye contact, for example, the more advanced social behaviours like pointing or language will be compromised. So what we think in some cases of autism is that this might be where the initial, or at least an initial, vulnerability might be there. So as I said, this idea of sticky attention, not being able to disengage and then re-engage in other information, as well as less sensitivity to eye gaze or to human speech sounds. No, so we're thinking that this here might be an initial point of vulnerability for infants on the spectrum. Now, if they're not showing these abilities, of course, these later and more advanced social abilities will also be compromised. The great thing is that this provides us with the most wonderful opportunity for intervention, and this is what we've really been concentrating on. How can we use these early vulnerabilities and harness that knowledge to develop an intervention? So what we're conducting with the CRC's investment is something called the the Australian Infant Communication Engagement Study, or ACES. Now, any researcher knows that the most important thing about developing a research study is develop an acronym. So we went with ACES, and this is what we've got at the moment. So I'll be referring to ACES. So what this therapy involves is parent mediated. Now, every therapy should involve parents. It's so important. What we're talking about here is not involvement of parents, but we're actually talking about mediation of the therapy by parents. That is, the parents are the people who deliver the therapy. The advantages for this are quite significant, particularly when we're talking about infants. The first is the time exposed to the therapy. If parents can enact this in their daily behaviour, it's going to be far more powerful than an hour-long visit to a clinic. The cost efficiency, by not having to go to a clinic, it's far, far cheaper for families, both in terms of finances as well as time impost. And then, of course, the effects on the parents. By upskilling parents and helping them feel supported during a rather distressing time in their lives, the effect of that on therapy efficacy or effectiveness is very, very powerful. So I think parent-mediated therapies are a very important way to deliver therapies at this very early stage of development. So the ACES trial, what we're doing is helping upskill parents to help them respond to their infant's different communication style. What we do is we use video-based modelling. So we essentially film parents interacting with their infant, usually between 9 and 14 months of age. Then we go back over the video and teach parents, look, there's an important opportunity for you there to do this. Oh, there's another opportunity for you to do this. And it's basically providing a really safe, supportive environment to help parents understand how to respond to their child's different communication needs. Now, the protocol, it's actually 10 sessions rather than 12 sessions, my apologies, over 5 months, and it's delivered with a speechie, and we come to the parents' houses, and there is a daily practice plan. A pilot trial was conducted. So I'll go back. The pilot trial was conducted by Jonathan Green and colleagues in Manchester, and they really were the ones that spearheaded the development of this intervention. And here are a couple of videos of before and after, before the therapy and after. And I think just to show you through these videos some of the changes that were made. So here's the first video. I'll see if I can play it. Okay. So this is prior to the therapy. Now, what you're seeing here, I'm not too sure, you probably can't actually hear the audio, is you're seeing that immediately you see the mother is side on to the child, which is not an ideal way to interact socially. Most of the interaction is directed towards the object rather than directed towards social communication. And then you can also see that the mum is leading the interaction rather than following the child's lead, which actually doesn't promote social communication as well. Now, this is, for infants who are developing absolutely typically, there is nothing wrong with this interaction style at all. In fact, this is how I interact quite with my young bub. What we do know, though, is that these interaction styles that might be suitable for infants who aren't developing without difficulty may not be ideal for infants who are developing a little bit differently. So we need to find ways to adapt that infant's communication needs. So after about 10 sessions and 5 months of therapy, this is what the interaction style was looking like for the mum and the infant. I should say that this is an infant sibling. So it's a sibling of a child with autism, and this child was showing some warning signs, early signs of autism, and that's why they were enrolled into the trial that was done in the UK. And so this is after. What you're seeing here is immediately the position of the mum is corrected. Now what you're seeing is they're playing a game, which is great because it promotes social communication. And you see a few eye flicks back and forth between mum and the infant, and that's wonderful, just beautiful social interaction. So what you're going to see soon is that the infant starts banging things together. Now the mum immediately recognises that and starts imitating, which is great because she's now turned it into a game. And all of a sudden you see this beautiful back and flow of social communication between the mother and infant. Just such a wonderful, joyous interaction. And that's what we're seeking to do through this therapy. Okay, so this is quite a complicated slide, but it's essentially showing you what is happening in the intervention trial. The trial is being based in two places, one in Perth and the other in Melbourne, which is led by Christelle Houdry, and other key investigators are Jonathan Green and John Ray, Cheryl Dissanayake and Josie Barbaro, and many, many others, I should add, and I'll have a slide showing who else is on it. What we're doing is we're recruiting infants between 9 and 14 months of age who are showing all early signs of autism. Those 5 risk behaviours that I showed you before, those 5 likelihood behaviours. What we're doing is that once they're coming into the, to see me, we're randomising them. Half are receiving the treatment that I showed you just then, and half of them are receiving the treatment as usual, which will be a parent information workshop. After that, we're following the children up immediately after the 5-month therapy at 14 to 19 months, and then again at 20 to 25 months, and then we're following them all the way to age 3 to see which children go on to develop a diagnosis of autism spectrum. And again, what we're seeking to do here, it's really important you understand that, is not prevent autism in any way. We're seeking to do 2 things. One is to upskill parents, to help them feel supported during a time that can be distressing, and also help them feel that they can contribute to their child's therapy, because ultimately they're the biggest weapon. Families are the biggest weapon in helping to prevent disability, and that's the second aim. We're seeking to prevent the disability associated with autism. We're trying to help children develop language, to develop independence, to develop intellectual abilities. That's our aim. So this is the ACES a team. It's a huge team, and again we're very thankful to the Autism CRC support for this trial. The results will be released at the end of 2017, and we've already enrolled quite a few infants into the trial as well, and it's a world first trial, so it's very, very exciting to look at an intervention at this age where the brain is at its most changeable. So this is my last slide here. The summary: the clinical pathway that we have at the moment isn't working, where everything is geared around identifying children with autism, getting that diagnosis, and then providing therapy for autism. The way that we can transform lives along that clinical pathway ultimately will be limited. We need to explore another paradigm, and that means identifying kids with a high likelihood of developing autism early on, and then providing intervention at a very early age. And ultimately, for health systems, we need to develop an ethical and economic case. We need to say prove to the health system that investing in 12-month-olds, that money that is spent investing in 12-month-olds will be offset by the improvements in long-term outcomes, both in taking individuals off welfare and getting them into the tax system, and happy and healthy lives for families and their children in the long term. So here's some acknowledgements. Just thank you to everyone involved in this. I'm the one that gets to present, but there is a large team involved, both within and without the CRC. So thank you very much. Just last slide here is that if you would like to get our research updates, and again we do a 60-second video every week, please do go onto this our Facebook page and like us, and you'll get those videos automatically. So thank you very much for listening. That's the end of the presentation. I'm not too sure how quickly. We've got 10 minutes left for questions, so please do fire them through now if you have any. Thank you very much, and I'll just start now. I see a question up there already. It says, what are your thoughts and comments on the DSM-5 requirements to give a severity rating, given that the evidence shows the symptom severity has minimal predictive power? Look, I completely agree. I think that's a really, really good point. I do think that identifying, or at least better targeting a diagnosis as to what a child is looking like at the point of diagnosis is important. So I do think this is a really important step by the DSM-5 to include those symptom severity ratings, but and not just because of it helps clinicians understand the level of abilities of an individual, but also because it will potentially help funding systems to plan for the future needs of individuals on the spectrum. So I do really think it's an important step. But as you've so rightly put in your question, it is so important to recognise that at the moment there is no evidence that symptom severity has predictive power. That baffles me. It absolutely baffles me that that's what the predictive, that's what the empirical evidence says. So thanks for the question. Another one's just popped through. Great to hear about this. Thank you. And it seems like this is how this person is trying to organise their organisation, so that's terrific. Look, I absolutely don't think we're the ones that are developing this. I think this is the clinicians have cottoned onto this a long time before me. What we're seeking to do for you is to provide the economic data that shows that investing in these kids will provide a wonderful economic return. And ultimately, I'm sorry to put it down to economics, but that's what governments listen to. But also what we're seeking to do is show and provide empirical evidence that the long-term outcomes will be improved. The question here, oh no, it was just a comment. It was basically just saying that that's what they're trying to do. So whoever this person is, please do keep in contact, because we're seeking to provide the evidence for you to use to your paymasters as well. Are there any other questions that people might have? Well, there's nothing coming through. So please, if there are any questions other than, oh, hang on. Another question just popped through. What are the facial structure differences? That's a really important question. Thank you very much. The facial structure differences that we're identifying, and again, the first paper for this will be published pretty soon, is we're seeing that there might be slight masculinization of the faces, of children's faces, of kids on the spectrum. And that's a really interesting finding in the context of an existing theory with regards to how prenatal testosterone might contribute to the developmental pathway to autism. In particular, that exposure to increased levels of testosterone might contribute to the developmental pathway for autism. So what we're actually identifying is that slight masculinization of the faces in some children on the autism spectrum, which is really interesting, and we certainly hope to be following up on this. In fact, we are, and we've been collecting a lot of data on this recently, and we have a lot of data in the realm of hundreds of faces now, and that we hope to be looking at this more closely. Another question just popped through. It was pleased to see the last video the mother was relating to the child rather than to the activity. I feel that this authentic presence, as they call it, is vital, and I completely agree, and that is exactly what families, we're trying to upskill families about. And of course it's difficult when they have a camera stuck in their face, but a great deal of this therapy is about clinical rapport, and that's why I like this therapy in particular, because there's a lot of clinical skill involved. It's really upskilling parents about how to engage with their child rather than an object, and how to help them promote social communication, because the more a child engages in social communication at those very early stages, the reduction in the entrenchment of disability will appear. And that's very important. Right at the start I talked about the reduction of the entrenchment of disability. If we can have a child starting to engage in the social world when they previously may not have, the reduction in entrenchment of disability will be quite significant. Another question that popped through. Would there be a case of rolling out this kind of parent training on a broader basis, as it seems it would benefit most parents and children? That's a great, and the example is the baby college in the USA. Absolutely, yes, 100%. What we're looking to do first is understand how this would work in a targeted way, in particular infants that are showing early signs of autism. So we, the broader team, Jonathan Green and his colleagues, have developed this therapy specifically for infants showing early signs of autism. But you're absolutely right that there are elements of this therapy that any parent can benefit from. So there are attachment elements in this therapy, as you probably noticed, and some of the feedback, for example, in the first couple of sessions that we seek to teach with families, is that they are and the primary caregiver, that they are the most important person in their child's life. Often that's not self-evident to families, and just that realization, and so we can show that to them through videos, that the child is always referring to them, and that means they're the most important person in their lives. That is such, and I've got goosebumps now talking about it, that is such an important thing for families to realize, and that goes beyond infants showing early signs of autism. Our plans are absolutely to look beyond infants showing early signs of autism. This is the very first step, and what we want to do is show evidence that this might improve the development of kids on the spectrum, but certainly I think a great avenue for this beyond this is to start looking at, for example, maternal and child health nurse classes. Maternal and child health nurses, I think, are with parents and GPs among the most powerful weapons for identifying and upskilling parents very, very early on in their child's development. So I think that's a really important avenue. So I think we've probably hit time there, but can I just say thank you so much for logging onto the webinar. We had great numbers roll up to this one. Please, if you are interested in knowing more or interested in getting in contact with me, please contact the CRC and they'll pass on your contact details. But in the meantime, please keep engaging with the Autism Cooperative Research Centre. We love people logging onto these webinars. If you're interested about this research, please do contact me because I think it's absolutely fascinating, and I think it has great potential to improve the lives of many people. So thank you very much, and I guess I'll see you all very soon. Thank you. Bye.